I have a lot to show you in this video. We're at Lesson 13C and solving multi-step percent problems. There's links in this description to help you, so remember, okay? So there's going to be percent problems that'll need more than one step to find the answer. We have to go over the words carefully and determine the information needed for a solution, and think of that triangle we've been using for base, rate, and part. And think of that formula, I equals PRT, for simple interest problems. The interest equals the principal times the rate times the time. And remember, percentages are based on parts of 100. If a shirt is sold at a 20% discount, then 80% of the original price is the final cost. We do 100 minus 20 equals 80. 100% minus 20% equals 80%. So here's our first example. Tala bought a package of 100 daffodil bulbs at a 15% discount off the regular price of $76.07. How much did she pay? So the first thing we have to notice is that we have to be careful. We don't need that 100. That's a trick. It doesn't matter how many bulbs are in the package. There could be 3 bulbs in the package. It wouldn't matter. The package costs $76.07 and has a 15% discount. All right? So the base is $76.07. Our rate is 15%, so we need to find the part. Which one of these expressions is the right one to help us solve it? Well, you have to be careful. We're not going to subtract 0.15. That's like subtracting 15 cents. We're not going to add 15 cents. We're not going to subtract 85 cents. That's the balance of 15% from 100% would be 85%. We're not going to subtract it. That would be like subtracting 85 cents. 76.07 times 0.15, well, that'll tell us what 15% is, but it doesn't tell us the final price. So it'd be number 5. We find what the price will be after we take away the 15% discount. It would be $11.41, and then we subtract that from the 76.07. We could also look at it as, if we're taking away 15% and we want to find out what 15% is, well, the balance is 85%, so we could just find what 85% of this is, and that would be the final price. If we did 76.07 times 0.85, that would give us the $64.66. That's 85% of the original price. 100% minus 15% equals 85%. So there's either 2 steps here, or if there's really 2 steps here also, because you would be changing this 100% minus the 15% to get 85% as a decimal, and we'd multiply it, see? So be very, very careful about the words in the problem, and if you need to actually solve the problem on scratch paper to figure out what the right expression is, well then do that if that's what's going to help you, okay? We have more examples here. Dave makes homemade jams that he sells at craft shows and fairs. If his cost is $1.82 per jar of jam and he needs to make a 40% profit per jar, how much should he charge for each jar? So right here it says profit. So we know there's going to be 40% added onto this $1.82. Which expression is the right one to help us? Well, we need to know 40% more of $1.82. So we're not going to subtract. So we know number 1 and number 4 aren't right. What we would do is number 2. We would find what 40% is by turning the 40% into a 0.4 or a 0.40 as a decimal, and whatever that comes out to, we would add it to the $1.82. And again, if it helps to actually solve it to see what you did, then do that if that's going to help you, okay? Now this one's a little trickier. A pair of jeans marked down 25% to $44.99. What was the original price? We find the rate that represents the sale price. So 100% was the original price, right? It's got a 25% discount. That means it's 75%. That means that $44.99 represents 75% of the original price. We can divide the $44.99 by 0.75 as a decimal. And it'll give us 59.9866, which, because it's money and there's only 2 digits after the decimal point, would round to $59.99. We cannot just multiply the $44.99 by 25%, which gives us $11.25. We can't just multiply these together to find 25% and tack it on to that, because that would give us $56.24. That's not $59.99. So using proportions like we've done, this would be the part, the $49.99, right? And we're trying to find the base, the original price. This $49.99 is 75 out of 100. It's 75% of 100, isn't it? We multiply the 44.99 times 100, which gives us 4,499, and then we divide it by the third number, right? The 75. That gives us $59.99. That's basically what we did here. We did 44.99 divided by 0.75. See, there's a decimal point here, and there's a decimal point here. That's why it worked. There's no decimal point here. There's no decimal point here, so it gave us the same amount. See? I've got more examples if that's really confusing, so hang on, okay? A lamp costs $54 on sale after a 40% discount. What was the original price? So if $54 is after a 40% discount, well, 100% was the original price, which is what we need to find, and after taking away 40%, it equaled 60%. That means that $54 is the 60%. We find the rate that represents the sale price. This 60% is $54. We can divide 54 divided by 0.6, that's the 60% as a decimal, to get $90 for the original price. Now, using proportions, what we do is the $54 is the part. We're looking for the base. It's 60 over 100. It's 60 100ths as 60%, right? We multiply across here 54 times 100 and get 5,400, and then we divide it by that last number, the 60. We get a 90. There's no decimals here, and that's why it came out as 90. Where here, we had a decimal, see? Do you see that? Now, we cannot just multiply 54 times 40% as 0.4 or 0.40. That's going to give us $21.60, and when we tack it back on to the $54, we only get $75.76. That's wrong, okay? So you could do it as a proportion, okay? We know that's the part. We're looking for the base, and that's the percent over 100. Okay? And if that helps you solve it and is easier for your head and it's going to help you pass the test, well, then do it that way. Use proportions. Okay? Look at it this way. A lamp costs $60 on sale after a 40% discount. So now we're going to use round numbers. What was the original price? Well, 100% was the original price. They took away 40%, and now it's 60%. That $60 is the sale price, the 60% price. When we do 60 divided by 0.6, that's 100. That makes sense in our head because if it's $60 after a 40%, that's 100, isn't it? 40 plus 60. We divide it by 0.6, and we can use proportions. See, we can do 60 as the part. We're trying to find the base, and we've got 60 over 100, our percentage over the 100, and we come out with $100 after we do the division. We cannot just do 60 times 0.4 and tack it on. That would only be $24. When we add it to the $60, that only gives us $84. See? So that doesn't work. You have to find the proportion, okay? Or you have to divide it by that percentage as a decimal, okay? Lisa put $480 of clothes on layaway. She paid 10% as a down payment and will pay the balance in 6 monthly installments. Which of these expressions can be used to find the amount of each monthly payment? Well, if you remember that fractions are little division problems, the answer is number 4. We're going to subtract 10% from 480. So we need to find out what 10% is first. That's this part. $480 times 0.1 or 0.10 is going to give us the 10%. And then once we find that out, we need to subtract it from the 480. That was her down payment. That was the original amount. And then we need to split it into 6 equal installments, don't we? So fractions are little division problems. We're going to divide this whole thing by 6, okay? All right. I have a couple more very good examples for you. ABC Company employs 1,200 people, and they laid off 10% of their employees in June, and in August they laid off another 10%. How many employees were laid off? So out of the 1,200 employees, how many were laid off? We cannot add the percentages together and just take it away from the 1,200. That will not work, and you'll get a wrong answer, okay? We have two steps here. We need to take away 10%, find a subtotal, and then take away another 10%. In June, 10% of the people were laid off, so 10% of 1,200 is 120. See? We multiply this by 0.10 or 0.1 to find out what the 10% was. That's 120. We subtract that from the original 1,200. That means in June, there were 1,080 people still employed there. Then in August, out of the 1,080 people, they took away another 10%. We find out that that's 108 people, and when we subtract it from the 1,080, that means there's 972 people left. Now it asks how many were laid off, not how many were left. So we need to take the 1,200 minus the 972 to find out that there were 228 employees laid off. Wow, there were 5 steps to that. See that? It would be wrong to group the 10% from June and the 10% from August together. You can't just take away 20%. That means 240 people were laid off. See? We can't do that because in June, there were still 1,080 people working there when they took the other 10% away. That's a smaller amount. See? See how important it is to do it in 2 steps? So now let me show you what happens at the store with a coupon. A shirt has a regular price of $35 and it's on sale for 10% off the regular price. We have a coupon for 20% off, which we can use on any regular or sale item, okay? So the cashier discounts the shirt by 10%. So we multiply $35 times 0.1 as a decimal or 0.10, and we find out that 10% off is $3.50. We take that away from the $35, and our subtotal is $31.50. Now she's going to apply our coupon, our 20% coupon. 20% of $31.50 is $6.30. We take that away from that subtotal, and we get $25.20 for a final price. Did you know that that's actually only 28% off of the $35? Let me show you. If the cashier discounted the shirt, 10% and 20% added together to be 30%, 30% of $35 is $10.50. When we take that away from the $35, we get $24.50. That's a big difference, isn't it? So actually, if the cashier groups your coupons together, you're going to get a better price. But they usually don't do that. Beware there's a difference between combining coupons and subtracting them one at a time, okay? If they combine the coupons, you're going to get a cheaper price. They usually don't do that because they're in the business for money, right? So remember, when you see problems like this, you need to do them one step at a time. You need to take away 10%, get a subtotal, and then take away 10% from that subtotal, because that's different, okay? 10% of 1,200 is 120. 20% is 240. It's double that, isn't it? But that's not what happened. It got down to 1,080, and then they took 10% of that. See? So it's a different amount. So just be really, really careful. You should be ready to do the skill focus on page 149, and I hope everything goes okay. If not, try watching this video again or the ones that are linked in the description. And remember that saving 20% means paying 80% of the original price, okay? And that's what would represent that part, okay? Our next video is going to be calculators and percents. So I'll be showing you how to use a calculator on these percentage problems, all right? That's lesson 13D. And of course, I'm going to have a link to the fraction and decimal in the answer sheet 10D that we did before, if you need it. And it's how to write fractions and decimals in those grids that are just for one problem. And I'm going to have links to the previous videos for this lesson, 13A and 13B, and those grade 7 and Algebra I videos that help with percentages. Okay. I know this was a lot of information, but I really wanted to cover all of these so that you weren't confused. Okay. So remember, when you're taking away 2 separate percentages, you have to do it in 2 separate steps. Okay. You can't just combine them and subtract it. All right. Don't let it fool you. Watch out for words that are not important in the word problem. Okay. I believe in you. I think you can do this. We're almost halfway through this GED whole experience, so I'll see you next video. Bye.